Hi, welcome to D3 Engineering's booth at the Embedded Vision Summit. I'm Jason Enslin, Product Line Manager for our NVIDIA Jetson Systems and Cameras. D3 is an elite level partner with NVIDIA focused on embedded hardware, software, and sensors. Today we're going to show you a multi-channel demo on the NVIDIA Jetson Xavier using multiple modalities of cameras. The demo consists of an NVIDIA Jetson Xavier developer kit and D3's 16-channel GMSL2 interface card. GMSL2 is a power and data over coax standard that allows us to mount the cameras remotely from the Jetson Xavier. Also on board the 16-channel card is an FPGA, which allows us to do multi-camera synchronization. We have two AR0234 cameras made with on-semi technology and a time-of-flight camera made with analog devices technology. D3 Engineering designs and manufactures these cameras in our ruggedized form factor for harsh environments.
Before we launch into the demo, let's take a deeper look at the hardware and some example applications for this technology on the NVIDIA Jetson. First, let's look at the D3 time-of-flight camera module, the D3 TCM9036. This module was developed by D3 in partnership with Analog Devices and Arrow Electronics. It's a production intent modular design that can be customized and integrated into end products. The D3 TCM9036 uses 940 nanometer pixel illuminators, which are invisible to the human eye and provide better outdoor performance than other solutions that use 850 nanometer illuminators. D3 offers several different output format configurations, including MIPI CSI2, GMSL2, and FPD-Link 3. D3 is sampling these modules now for early adopter customers, and the open frame MIPI CSI2 version will be available on arrow.com this summer. Here we're showing some of the key specifications for the time-of-flight camera module. It comes in a compact form factor of about 2 inches wide, 2 inches long, and 1 inch deep. It provides 90-degree horizontal field of view with a resolution of 640 by 480 pixels. It can operate between 15 to 30 frames per second, depending on the desired range configuration. Now let's take a quick look at the visible camera, the D3CM AR0234. This is an environmentally sealed camera module rated to IP67. It features a 2.3 megapixel AR0234CS image sensor from ON Semiconductor. D3 offers the camera module with a 56-degree or 132-degree horizontal field of view. One of the key features of the sensor is the global shutter. Global shutter collects light for every pixel in the array at the same time. This makes it much easier to synchronize the camera with illumination, and in the case of a multimodal system where time-of-flight is used, the camera's exposure can be offset from the pulsed time-of-flight illumination so it does not corrupt the visible image. D3's status as an elite-level camera partner with NVIDIA allows us to tune and optimize the image quality of the camera using the AGX Xavier's on-chip ISP. The cameras are connected to the Jetson AGX Xavier via D3 16-channel GMSL2 interface card. This interface card connects to the AGX Xavier's camera expansion connector and breaks out the 4 available MIPI CSI2 inputs. Each of the MIPI CSI2 inputs is connected to a GMSL2 hub, which is capable of multiplexing 4 cameras onto a single MIPI CSI2 input. This enables a total of 16 possible camera inputs. There's a small onboard FPGA that the AGX Xavier can communicate with to configure synchronization pulses. These hardware-generated pulses are passed up to the cameras via the GMSL2 back channel and provide a precise trigger input which starts the camera shutter time. We'll see this functionality in action in the demo. Here are some example applications that can utilize a multimodal camera system. Many robotics customers who are developing autonomous functionality have the need for SLAM and object avoidance. The multimodal system is great for this because cameras can be used in a complementary fashion to accomplish the goal. For example, a stereo pair of visible cameras can provide a coarse 3D measurement of the environment, and the time-of-flight camera can provide a more precise 3D measurement as the robot approaches an obstacle. Object identification, measurement, and tracking is also a great application for this technology. The visible camera information can be used by a neural network to identify objects, and the time-of-flight camera can provide distance measurements and aid in tracking.
We'll start by showing you a time-of-flight demo that does object detection using a neural network that's available in the Analog Devices SDK. What we're showing here is the output of the time-of-flight camera. Time-of-flight uses IR illumination to measure the distance objects are away from the sensor. Warmer colors are closer to the sensor, cooler colors are farther away. What we're running is a mobile neural network that is performing object detection. So it's detecting here a person in a chair and also giving the distance that those objects are away from the sensor. D3 Engineering uses demos like this as a starting point for our custom product development. We can take a demo like this and adapt it to our customer's use case. And now we'll start up the camera synchronization demo. We're using two AR0234 2 megapixel global shutter cameras running at 60 frames per second. We're imaging a high frequency shutter timer, and you can clearly see in unsynchronized mode, the LEDs are not in the same position in each of the two camera streams. So now we'll switch over to synchronized mode, and using the D3 software, we can easily enable that with V4L2 control. The FPGA on D3's 16-channel interface card is generating a synchronization signal that is sent up to both of the cameras. And now you can clearly see the LEDs are in the same position in both of the camera streams. And that's all we have to show today. As you've seen here, D3 Engineering's hardware and software, along with the NVIDIA Jetson, can help get you started on your next Edge AI product development. Thank you for joining us at our booth today, and we're ready to answer live questions.